All right, and I asked, hey, where do we see these on aircraft? You might be pretty accustomed to this. If this is the fuselage of our plane, this is our wing. There's a great big cantilever right there. Right. Now, some construction, this is kind of tacked on the outside. Sometimes this beam goes all the way through. In that particular case, we would see something closer to our overhanging design. But I would say in this particular case, it looks like this is kind of a stub on the outside of our column. It's very clearly welded here on the top and bottom. You can see they added a big plate there to stiffen this up. Got a stiffener plate here. All right. So those are some examples of how we see these in real life. Now here is a better example of a moment connection up close. You see that versus the simply connected one that we saw before, that we have pretty strong weld right there. Those flanges, the top and bottom part, we call this the flange. Pretend that I can write today. I'm going to call this top and bottom part. This is the flange part of the I-beam, right? If we're looking at it in this case, whoop. This is the flange. And this middle part we call the web, holds it all together like a web. And then there's some stiffener plates that they add here and here to make that column really nice and stiff, to make sure that the flange on our column doesn't get soft and bend. Now, one thing you might notice that's kind of interesting here, if you look here, there's some parts missing. And you're going, Albert, there looks like somebody took a big cut out of our flange here. Why are there this sort of weird dog bone pattern? If I'm looking at it from the top, I'd see something that looks like this. We actually call this a dog bone because it looks like one. And it's got a very important purpose. What it does is actually creates a really soft place out here. So if this building is going to go through an earthquake, and this thing starts to wobble like this, there's somewhere for that to bend. This basically acts like a mechanical fuse, right? Just like an electrical fuse, it's designed to break there, right? And that's going to protect the building, because now that we have this fuse here in the middle of this structure, in the middle of this member, this is going to be nice and flexible versus as if it failed at the welds. If these welds failed, if they failed there, we'd see this fail almost instantly, right? We wouldn't have a whole lot of warning. But if we're bending here, we're going to see that whole building flop around. We're going to see that happen. We've got some ductility. That's going to save lives. So that's the idea behind this, is it acts as a mechanical fuse. It's going to make it safer. All right. So let's stop here. We're going to do some clicker questions.